Selamat sejahtera and very good morning to our beloved lecturer, Dr. John Siatling. We are from Group 1 and Section 3. Our group project title is Car Audio in Automotive Field. I'm Fidas bin Talib and my group mate is Ali Afika, Muhammad Ikram Daniel, Muhammad Aziz and Nur Nazira Syazwani. First of all, I'm going to present about introduction. Digital signal processing in a car audio is a device that allows you to manipulate signal from various input and allow your speaker to play in a way that they were designed by cutting out distortion and increase overall volume. One benefit of having your installer tuned with DSP function is the knob of analog processor accuracy. This is because DSP use mathematical algorithm to alter the audio signal and they are very accurate. Car audio systems are made up of multiple speakers, each designed to operate within a specific range. As an example, tweeter handle high frequency information, mid-range driver handle majority of vocal, and woofer and subwoofer cover low frequency information. That's all for me.
Assalamualaikum. My name is Nur Nazira Syazwani with Imam Fauzi, DE 200113. Now I will talk about the methodology of our project. So as we can see, this is a block diagram for the car audio system in a car. So it starts from the power supply, which energize the tuner, and then go to the micom or the signal processing, and then from there the micom control the LCD controller and output at the LCD display, while at the signal processing the signal goes to the amplifier and the output will go out to the speaker. And then for our project we're using FIR. For our project we're using FIR filter, which FIR filter is a filter structure that can be used to implement almost any sort of FIR filter is a filter structure that can be used to implement almost any sort of frequency response digital. And FIR filter is usually implemented by using a series of delay, multipliers, and adders to create the filter output. This diagram shows the signal flow for the general FIR filter. The coefficients C0 to C1 are the taps, and so for a n length FIR filter there are n taps and n1 sample delay element. The filter order is n1. But a short FIR filter cannot do very much. Longer FIR filter become quite powerful by essentially blending a long history of audio sample to cause level and phase changes at different frequency in controlled ways. Our project is including sampling, digital filtering, and FIR filter. That's all for me. Thank you.
Hello everyone. Today I'm going to present to you about how to generate the MATLAB code for our group project for course digital signal processing. So for our group project, we would like to develop a lower pass filter for a car radio and we convert it into band pass filter. So from here, you can see that the first code that I highlight is the code to generate the noise from the car radio. So when we run the code into the MATLAB, the output of the graph will display like this. The car radio audio noise, which is frequency versus magnitude. So that is the graph. And the second code over here is we apply the lower pass filter in FIR filter, which is analog to analog filter. So when you run the code that I highlight, it will display the first FIR filter, which is over here. So it in magnitude 0 until 25 kilohertz. So this is the first filter. And for the second code that I highlight, we increase the sampling rate into 100, which is become 200, and the second filter will display like this. So this is the second filter, which is when we increase the sampling rate, the value will drop to a lower much frequency. So the value will go decrease in frequency. As we can see for the third graph, if we generate and we run into the MATLAB, it will display the transition width inside the FIR filter of the lower pass filter, which it is added for frequency center frequency value inside the FIR filter of the lower pass filter. And next, I'm going to show to you how to convert lower pass filter of FIR filter into a band pass filter. So this is the code that we write. The ones that I highlight is the code that we generate inside MATLAB to produce the lower pass filter, to transform the lower pass filter of FIR filter into a band pass filter. So when you run this code inside MATLAB, it will display inside our spectrum analyzer like this. So from this graph, it is a transform from lower pass filter of FIR filter into band pass filter, which is the sum from FIR filter sampling rate of 100 and FIR filter sampling rate with 200. So it will produce a band pass filter which range from negative 25 kilohertz to 25 kilohertz with zero magnitude. So that's it for me. Thank you.
Hello and greetings to our lecturer, Dr. Chong. My name is Alia Afika binti Abdul Talib and I will do the presentation about analysis and discussion for our group project. Okay, the graph at the side that you can see is a graph of car radio audio noise. The noise produced due to the power line and moving electric motor. Noise is shown when the magnitude values does not reach the value of 0 decibel. Next graph is about application of the FIR filter that we use, which is analog filter. The purpose why we added FIR filter to the car radio audio is to decrease the noise at a certain frequency rate. And in this simulation, we set the prototype frequency equal to 20 kilohertz and sample frequency equal to 96 kilohertz. And also sampling frequency equal to 100 kilohertz. By doing this, it can produce 0 decibel magnitude but only lasts until 25 kilohertz. Okay, next graph is decreases of frequency rate. When sampling frequency, we raise it to 200 kilohertz, while prototype frequency remains same as 20 kilohertz, and sample frequency remains same also, which is 96 kilohertz. So what we can get is when we increase the sampling frequency, it will cause the magnitude value 0 decibel, but only less until 22 kilohertz. Okay, next is the transition width that added to the system. When center frequency is subtracted by the prototype frequency, it causes the graph filter remains still at magnitude 0 decibel, but only less at frequency rate of 23 kilohertz. Okay, last graph is the conversion from lower pass filter of FIR to the band pass filter. In this simulation, we use formula 0.5 multiplied by F2 plus F3, which F2 is sample frequency equal to 100 kilohertz and F3 is sample frequency equal to 200 kilohertz. 0.5 in this formula indicates the forgetting factor in the MATLAB toolbox that we use. And the conversion of lower pass filter to band pass filter can extend frequency point value when the magnitude value is equal to 0 decibel. So that's all from me. Thank you.
Assalamualaikum, I'm Muhammad from the name Lazaruddin. So I will continue the last part of our assignment, which is conclusion. So our assignment are providing the DSP based design for an automotive or automobile audio signal system, which is we focusing to the car system. So we are using the FIR filter based on the characteristic of the signal, and the waveform and the spectrum clearly show the effect of our filtering. So the algorithm is easy to implement to our DSP because there is short running duration and clearly regular. So in other hand, DSP will improve our automobile audio signal, because when you plug in the DSP, you will know the impression that soundstage is just better, more articulate and more clear. And the main part, or the most important thing about the best of DSP is when the music coming out from the amplifier, we will be more heartfelt about that music, about that sound, for especially. So that's all from me. Thank you.